The gravity die casting is one of those processes that is popularly used for both medium and high volume production process. Under normal circumstances, this process uses permanent mold, thus, it is easier to achieve a near net shape products. This die casting capability varies from one manufacturer to the other. That is, there are those companies that use the automated systems whereas others use the manual systems. Again, the weight of the final product that can be cast depend on the type of machine. The gravity die casting technique has been adopted by most companies due to the fact that it reduces the production cost. The tooling that is used in here is cheaper than those used in the high pressure die casting. What does the process involve in gravity die casting? Unlike the high-pressure die casting where the molten metal moves into the die due to high pressure, this die casting technique depends on gravity. It is noted that, there's no any other force that is applied to facilitate the flow of molten metal. This metal parts manufacturing process is suitable for non-ferrous alloys. That is, copper, aluminum and zinc alloys. It is a manufacturing process that is mainly used to produce heavier metal sections. However, the parts are thinner as compared to those produced by sand casting. Gravity die casting process involves four major processes. 1. The mold should be heated, sprayed with a lubricant and then closed. The lubricant helps to control the temperature of the mold. 2. The molten metal is poured in the mold and allowed to cool. 3. The die is opened to remove the metal cast components. This can be done with the help of ejector pins. 4. The die is prepared for the next casting process. As mentioned earlier, the gravity die casting can be used to manufacture components with complex shapes. Just to mention a few, examples of products that can be manufactured using this technique include diesel engine parts, automotive air cylinder, water pump and turbocharger housings, pipes, flanges, water pump housings, air conditioning systems, cylinder parts and valve flow systems, various small aluminium parts and components. The automated systems of gravity die casting is tilting technology machine. It is a low turbulence version of the gravity die casting process. As illustrated in Figure 1, mold is tilted towards the pouring side, resulting in minimal metallic static casting height, or a pouring basin or gooseneck is filled in what is called the D'Urville method, as depicted in Figure 2. While the mold is filled, it is returned, tilted, to its normal position or the melt flows from the pouring basin and into the mold. This causes the melt to flow into the mold cavity with a low head and at moderate flow rate, as illustrated in Figure 3. This process is used for casting materials with a high propensity to oxidation and foaming, such as aluminum gravity die casting, and aluminum-bearing copper alloys, in particular brass gravity die casting. The tilting towards the pouring side results in a low feed rate in the gate, helping to reduce oxide and foam formation, and the liquid metal can flow into the mold cavity smoothly and with low turbulence. When avoiding flow turbulence, this can also prevent air from being whirled into the casting flow and therefore air inclusions in the structure. At the end of mold filling, the hottest melt is located at the highest point or fills the risers, ensuring good post-feeding. This process uses special tilting gravity die casting machines, as exhibited in Figure 4. Now, let's take a look on machine-based tilting gravity die casting using D'Urville method. The main advantages of this manufacturing technique include the following. Better dimensional accuracy. Thinner wall can be cast though, they can be smaller than those of the pressure casting process. It reduces a number of secondary operations. It imparts desirable mechanical properties on the metal parts, for example, High tensile strength. The final parts have smoother surface than those made from sand casting. A faster production can be realized. It's possible to produce undercuts with the help of undercuts. The process has the following key disadvantages. It has high initial cost. Very complex shapes cannot be produced using this technique. The minimum wall thickness that can be die cast ranges between 3 and 5 mm. Now, we already finished gravity die casting. Please continue to part 3 on low pressure die casting.